Hello everyone. Today I'm here with a new presentation on the subject manufacturing process. Okay, so the topic I'll be covering is ferrous material. There are various materials in engineering. We can classify it into ferrous material and non-ferrous material. So ferrous material are those material which constitute carbon as its main constituent. Okay. So the topic which I'll be covering is ferrous material and different types of ferrous material. Okay, first of all we have the iron. How it is produced? Production of iron is with the help of blast furnace. Production of steel, basic oxygen furnace, electric arc furnace. The chemical symbol is Fe. Its melting temperature is 1353 degrees centigrade and it's boil at a temperature of 2700 degrees centigrade. The purest form of iron comes from sky in the forms of meteors. Pure iron does not rust in water. Iron rusts because it contains impurity. Okay, so this is an important point, that the iron rusting of iron, the main cause of rusting of iron, because there are certain impurities present in the iron. For that only iron rust, but the purest form of iron, it never rust. But the purest form of iron is not available anywhere. So our day-to-day use, the iron which we are using, it become rust in the coming time. Pure iron is seldom used in industry because it is too soft. Okay, and it can be scratched with fingernail. So the pure iron is very soft, which cannot be used in any industrial component. Okay, iron is used in three forms: cast iron, wrought iron, and steel. Okay, and now we have the iron ore. Iron is not pure as it comes from iron mines. Types of iron ore are hematite, Fe2O3, magnetite, Fe3O4, pyrite, limonite, and taconite. Okay, first is magnetite, Fe3O4. It contains 72.4% of ferrum. Its color is black, gray, or blackish in color. It is a magnetic material in rock or segmented rock. Okay, next is hematite. Hematite chemical formula is Fe2O3. It contains 40 to 65% of ferrum. Its color is grey, blackish, or red chocolate in color. It's common ore from iron. It is present in rock. Next is limonite. Limonite chemical formula is Fe2O3, 3H2O. It contains 20 to 55% ferrum with 40% of water. Its color is yellow, orange, red chocolate, or chocolate black. Found in loose and sedimentary soil known as dehydrating halimite. Okay, next is iron carbonate. It contains less than 30% of ferrum. Its example is siderite. The color ranges from yellow to dark brown or black, and it is also found in sedimentary rock. Now, characteristics of iron ore. The grade is composite of iron ore. Compactness is moderate. The purity form is low impure, and uniformity is in composition. Next is pig iron. So making pig iron is the first step in the purifying of iron. Okay, so when we take out iron from any form, so the first form to make the iron pure is to produce this into pig iron, and then from pig iron we make it steel. Pig iron is produced when the impurities are burned out of iron ore in blast furnace. Okay, blast furnace, as I have already told, we can use blast furnace with the help of fire and all, or with the help of electric setup. I will not be discussing about the furnace because that is not a part of this topic. So next I move on to the next component. There are two main kind of steel. Okay, now I'll coming into steel: plain carbon steel and alloy steel. So plain carbon steels are divided into three main groups: low carbon steel, which is called as mild steel, medium carbon steel, and high carbon steel. So first of all, let us discuss about low carbon steel. It contains about 0.05 to 0.3% of carbon. It has good weldability and machinability. Its tensile strength is very low and very ductile, and it's soft. It is very ductile and soft in appearance. Its main application is for body of washing machine, wire, steel pipe, screw and nut. It is used in this washing machine, wire, steel pipe, screw, nut, etc. in manufacturing of this component. Low carbon steel is also used for forge work, rivet, chain and machine parts that we do not need great strength. Next is our medium carbon steel. Medium carbon steel contains 0.3 to 0.6% of carbon. Medium carbon steel is stronger than low carbon steel. It is also more difficult to bend, weld and cut than low carbon steel. Balanced ductility and strength and has good wear resistance. Medium carbon steel is used for bolt, shaft, car axle, rails and other parts or tools that required strong metals. Okay. And next is high carbon steel. High carbon steel is also known as carbon tool steel. It contains 0.6 to 1.5% of carbon. The best grade of this steel are made in electric furnace. It is used to make such tools as drill, tapes, die, reamers, file, coal chisel, crowbars and hammers. Basically, high carbon steel are actually used for making cutting material. It is hard to bend, weld and cut. It is a very hard material actually. Now we have other elements in steel, and these are the elements which are found in steel. Silicons. Silicon is a chemical element found in rocks. It gives hardness to iron. Sulfur, a yellow flammable non-metal. Too much sulfur makes this metal weak and brittle, causing cracks. A little sulfur is added to some steel for better machinability. Next is phosphorus, a poisonous active non-metal. It causes brittleness and coarse grain in iron and steel. Next is manganese. Manganese is a greyish white metal, hard and brittle. It resembles iron but it is non-magnetic. It is used in making steel. Now what is the purpose of alloying of steel? The main purpose is to improve the mechanical properties such as improve tensile strength, improve toughness, wear resistance, corrosion resistance, resistance to heat, improve properties by heat treating. Effect of alloying material. Okay. Chromium, it gives hardness to steel and toughness. It also makes the steel grain finer and cause the steel to resist rust, strain, shock and scratches. Chromium, it is the basis for stainless steel, which contains 11 to 26%. It is a lasting bright silver gloss. Its important use in stainless steel is sink, tableware, pots and pan, cutting tool, dental tool, automobile part, fine measuring tools and instrument. Next is cobalt. Cobalt is an important metal used in making cutting tool alloy. This alloy includes high speed steel, cast alloy and cemented carbide. Its ability to improve the hardness of cutting tool when they are hot or even red hot. Next is manganese. Manganese is a hard, brittle, greyish white metal. It purifies and adds strength and toughness to steel. Manganese steel remains hard even when cooled slowly. It is so very hard that it is difficult to cut, so it is usually cast into shape. Next is molybdenum. Molybdenum is a silver white metal. It adds strength and hardness to steel. It and allows to stand heat and shock. Molybdenum steel is used for automobile part, high grade machinery, wire and fine as 0.1 mm in diameter ball bearing and roller bearing. Okay. Next is nickel. Nickel adds strength and toughness to steel. Nickel steel does not rust easily and it is very strong and hard. It is used for wire cables, shaft, steel rails, automobile and railroad car axle and armor plate. Next is tungsten. Tungsten is a rare, heavy, white metal that has higher melting point than any other metal. Tungsten adds hardness to steel. It gives steel a fine grain and allows steel to withstand heat. Tungsten steel is used extensively for making cutting tools. These tools need no special hardening treatment and will withstand high temperature. Next is vanadium. Vanadium is a pale silver gray material. It is brittle and consists corrosion. Vanadium steel can withstand great shock. It is used for spring, automobile axle and gear and other part that vibrates when it in use. Vehicle used in heavy construction commonly use vanadium steel. Okay, so vanadium actually, to reduce the vibration we can use the vanadium steel. Next is combination of chromium and vanadium steel. It is hard and has great tensile strength. It can be bent double while cold and it is easy to cut. It is used for automobile parts such as spring, gear, connecting rod and other part which must be strong and tough but not brittle. Okay, that's all for today. With this I come to presentation of ferrous material. Thank you everyone.